Yeah, this question, the pH of a 0.1 molar solution of the acid is 3. The value of ionization constant Ka of the acid is. So it's the question from ionic equilibrium. Now what is asked? The ionization constant Ka value. Now if I'm taking any acid, say Ha is any acid. Now it is undergoing dissociation and forming H plus ion and A minus ion. Of course, H plus exists in solution as H3O plus ions, hydronium ions. Now here, what is the concentration of the acid given? 0.1 molar. It means initially the concentration of Ha is 0.1 molar. It is 0 and it is 0. And after dissociation, now let alpha be or X be the dissociation. Let's take it X. X be the part dissociated. Right? Or the fraction dissociated. So Ha will be giving what? H plus of A minus, and here it's 0.1 minus X and X. Now what will be Ka equal to? Ka, that is the ionization constant, will be equal to the H plus ion concentration, A minus concentration upon Ha. Right? Now what will be the equilibrium concentration of H plus? It will be equal to what? C alpha. C is the concentration multiplied by the degree of dissociation. Right? It is C alpha and C alpha. So concentration, the equilibrium concentration of hydrogen ion would be C alpha. Now students, we know that this is the equilibrium concentration, and what is Ka will be then equal to in this case. Let's find out what is the degree of dissociation in this case. For that, what you need, alpha will be, say here it's the concentration of H plus ion is equal to C alpha. Now what is written here? pH of 0.1 molar solution of acid is 3. It means pH is 3. What is pH? pH is minus log of H ion concentration. Now let's solve it. So what is pH equal to? pH is equal to negative log of H ion concentration. Now in this case, pH is given as 3. So what will be the hydrogen ion concentration, students? It would be 10 to the power minus 3. Right? Now what we have got? The hydrogen ion concentration is equal to C alpha. That is the equilibrium concentration. So 10 to the power minus 3 will be equal to, what is the concentration of acid given? The concentration of acid is given as 0.1 molar, right? And alpha. So what will be the degree of dissociation? The degree of dissociation would be 10 to the power minus 3 divided by 0.1. What will come out? It will be equal to 0.01, right? Now this 0.01 is far less than 1. That is, what was the expression for Ka? It was H plus ion, A minus ion, which is formed after dissociation, and Ha. Right? The degree of dissociation is very, very less. So what can I write Ka as? Ka will be equal to alpha square C. Right? We can solve it. This is C alpha into C alpha divided by 1 minus alpha into C. I don't want to go into the derivation, but I hope you know this. How it's written is Ka is equal to, this will be C alpha multiplied by C alpha divided by 1 minus alpha into C. Now as alpha is very small, this 1 minus alpha can be taken as 1 and you'll be getting here as alpha square C. Now we know alpha, we know C. Can we find out the value of Ka, that is dissociation constant? Of course, yes. It is Ka will be equal to what was alpha? It is 0.01 alpha square, and what is the concentration given as 0.1. So what will be the value of ionization constant? It would be 1 into 10 to the power minus 5. Understood this question? It was very simple, students. You have to just find out the expression for Ka and then find out the degree of dissociation. So what will be the answer of this question? It would be 1 into 10 to the power minus 5. Right? So this was a very good question from ionic equilibrium. Now let's take up our next question.